Hi everyone, welcome to Max Measure. So in this video we are discussing about different approaches to obtain probability in different fields. So before discussing these approaches, let's recap what we have studied in a previous video. So in previous video we have discussed about some of the fundamental concepts in probability. So like a probability is a measure of uncertainty. So the is nothing but the each result of the experiment. The possible outcomes are the set of all possible results that can occur from performing an experiment. So the favorable outcomes are the outcomes of an experiment that align with the event of interest or the desired result. And a event is a set of one or more outcomes from a probability experiment that we are interested in. So and the equally likely outcomes are the outcomes of an experiment that have the same probability of occurring. And unequal likely outcomes are nothing but outcomes of an experiment that do not have the same probability of occurring, with some outcomes being more likely than others. So these are the fundamental concepts that we have discussed in previous video. So in this video we are going to discuss about some of the different approaches to define probability in different fields. So the approaches to the probability. So we have different fields like weather forecast, in gaming, in stock market, in medical testing, where we can define a probability so that we can predict a future. So for defining this probability in various fields, we have different approaches. So let's see one by one. First approach is classical approach to probability or a theoretical approach. So the classical or theoretical approach is based on equally likely outcomes. So this approach is typically used when all outcomes of an experiment are equally probable. So the formula for defining probability or getting a probability for an event by using this approach is the probability of occurrence of E equals to number of favorable outcomes divided by total number of possible outcomes. So if you consider an example like rolling a fair six-sided die and getting the probability of getting the 4. So the probability of getting 4 equals to 1 by 6. So here event is the 4, getting a 4 is the event. So the probability of getting a 4 equals to 1 by 6. Since this approach is based on equally likely outcome, first approach, and this approach is can be used in dice games, cards, and lotteries, particularly in games predicting. So next approach is experimental probability or empirical probability. So these probability is determined through actual experiment or past data. So the formula used to define probability is, uh, is like probability of event occurrence of event E equals to number of times event occurs divided by total trials conducted. So consider an example like flipping a coin 100 times and the heads lands 55 times. So the probability of getting head equals to 55 divided by 100. So this approach is used in weather forecasting, quality control, and medical research. So the next approach is subjective probability. So this probability is based on intuition, experience, or personal belief rather than calculation. So for example, a doctor estimates a 70% chance of patient's recovery based on his experience. So this approach of defining probability is used in business decision making, gambling, and financial predictions. So the next approach is axiomatic probability. So here axiom means nothing but a set of rules. So this probability approach is based on three fundamental axioms given by Henry Kolmogorov. So axioms to define the probability in this approach is there are three axioms. So first one is the probability of occurrence of E is lies between 0 and 1. So if the probability of occurrence of event E equals to 0 means the occurrence of event E is impossible, and if the probability of occurrence of event E equals to 1 means the occurrence of event E is certain, and if the probability of occurrence of event E is between 0 and 1 means so it is uncertain, it can be happen or may not. And second axiom is the probability of sample space, entire sample space equals to 1. The probability of entire sample space is 1. So and the third here sample space is nothing but a collection of outcomes, possible outcomes. And the third rule is probability of A universal B equals to probability of A plus probability of B. So these approach is used in mathematical modeling and theoretical probability. So a Bayesian probability. So this a probability approach that updates beliefs based on new evidence using Bayes theorem. So the formula used here is probability of occurrence of A where the event B is occurred equals to probability of occurrence of B where the event A occurred into probability of A divided by probability of B. So if you consider an example like a test is 90% accurate and only 1% of people have a disease. So Bayesian probability helps adjust the probability of being sick after a positive test result. So these probability is used in spam filtering, AI and medical diagnosis. So let's move on to another approach. It's a frequentist probability. So this probability is defined as the relative frequency of an event occurring over repeated trials. So formula used here is a probability of occurrence of event E equals to F by N, and here the limit is defined for N where N from N to infinity. So here F is the frequency and N is the number of trials. So if you consider an example like a cricket player scores a century in 3 out of 10 matches, so the probability of hitting century equals to 3 by 10, which equals to 0.3. So the applications where we can use these frequent test probabilities in statistical experiments and polling. So let's move on to the last approach, that is quantum probability. So a mathematical framework where probability are represented as wave function in quantum mechanics. So the formula used here is probability of occurrence of E equals to absolute value of psi whole square, where psi is the wave function of the system. So the probability of finding an electron at a certain location is determined by its wave function. So this is the example for quantum probability. So in the application where we can apply these quantum probabilities are used in quantum computing and cryptography. So these are all the different approaches we can use to define a probability in different fields. I hope this video is helpful, and thank you for watching. Have a good day.